day, everybody, and welcome to this class. In this class, we are going to be talking about the electric field. First of all, it is important to know that when a charge, particle, let's call this charge particle, let's denote it by Q, is placed on a region. If this is a positive charge, what will happen? There is a region around this charge in which when you place another charge, Q, let's call this one Q2. Q2, what will happen to this Q2 because of this Q1 is that Q2 will experience a force. I get it now? Yes, Q2 will experience a force. And this force is due to the electric field, that is being produced by Q1. So what is an electric field? An electric field is a region or space around a charge in which when another charge is being placed into that region, the charge experiences an electrostatic force. And this electrostatic force was defined in our previous class by Coulomb's law? By Coulomb's law. Are we together now? All right. So I said that electric field is a region or space around a charge in which when another charge is placed into that field, it experiences a force. What we are to talk about right now is electric field intensity. Electric field intensity. Electric field intensity. What is electric field intensity? Electric field intensity is also called electric field strength, It's also called electric field strength. And it is defined, electric field intensity is defined as the force, per unit charge. Write it down. Electric field intensity is the force per unit charge. Are you getting it now? Yes. So how strong? It's trying to define how strong this electric field is. Let's say we have Q1 producing a field, Producing a field such that when a charged particle is placed here, it will experience a force of let's say 5 Newton. Then Q2, another charge, or let's say yes, Q2, or let me use capital letter Q, produce another charge, And this field, produce another field. And this field, when a charged particle is placed here, it experiences a force let's say 500 Newton. What does that tell you? Both of them has field, But the strength of their field is not the same. Is it not? Yes, this is to tell you the strength of their field is not the same, So the strength of this field was able to produce 5 Newton force, and the strength of this field, which is greater than this, was able to produce 500 Newton. Are you getting it now? Yes, so electric field intensity, are you getting it? Is the force per unit charge. So the force charge we experience when placed in an electric field. So electric field intensity is a vector. So the unit it is given back as E. It's a vector, So I will explain why it is a vector. It's a force per over charge. Are we together now? Yeah, so electric field intensity is the force per unit charge. In notation, you can say F over Q. Are we together now? Yes. So from here, when we make F subject of formula, if we make F subject of formula, what will happen? we make F the subject of formula, that implies that F, right, because this is same thing as E. So that will be F is equal to QE. Are we there? We are together, right? So the first formula to note is this. An electric field intensity, the unit is given as Newton, right, per coulomb. The unit is given as Newton per coulomb. All right, let's continue. We already know, right? We know that F is equal to Q1, Q2 multiplied by K over R square. Is that true? If I plug in this formula here now, that means that my E will be equal to, right? So I'm substituting with K Q1 Q2 over R square, right? All over Q. Let's say my Q2 is same thing as Q, right? Yes. Now I will explain what we mean by our Q1, our Q2. Your Q1 is, right, is the charge we are talking about. Is the charge producing the field. Your Q2 is the charge experiencing the field, right? Same as this guy. This guy is the charge experiencing the field. So that means that we can denote this guy as Q2 because it's the charge experiencing the field. So substitute it here. What will happen? They will cancel out, right? This will cancel this. And when this cancel this, we'll be left with just E to be equal to K Q1 over R square. Are we there? All right, so the first equation to note, so I will summarize everything here. The first equation to note is that electric field intensity E is equal to force over charge, right? And also electric field intensity E is equals to KQ. This Q, we don't really need to put Q1 or Q2 over R square. Let me explain. This force here, this Q and this Q are not the same. This Q that is here is the charge experiencing the force. The charge that is experiencing, because we said that when we put a charge in the field, it will experience a force, right? Yes, this is the charge experiencing the force. And this is the charge producing the force, or the charge producing the field. But actually, you might not need to understand it to detail like that, because as the question comes, just using those formula, you can be able to solve either of the conditions. All right, so let's now explain electric field intensity as a vector. Let's now explain electric field intensity as a vector. If we say electric field intensity is a vector, why do we say it's a vector? First of all, let's recall the concept of a vector. A vector, are you getting it now? A vector is a quantity that has magnitude and direction. Are we together now? First of all, what is magnitude? We already know this right from our primary school days. Magnitude means size, number, value, right? Electric field intensity has a value because it is measured in Newton per coulomb, right? Yes. Now, the direction that makes it a vector is, for example, now, let's say we have a positive charge. We have already explained that a positive charge, Q, are you getting it now? We point outward, right? We point outward. We point outward. We point outward. Let's take a single direction outward. Where is it going? Are you seeing it now? So the direction is pointing out, is going out. Are you getting it now? So that going out signifies direction. So since direction has been signified here, it means that the electric field is going out. That means it's a vector. While for negative charge, it is pointing in. It is pointing in. It is pointing in. It's pointing in. Are you getting it? So this is it. Are we getting it now? Now let's drop another formula for electric field intensity. Let's drop another formula for electric field intensity. If I take two plates, right? If I take two plates like this, and like this, and I say let this be plus and let this be minus, and I connect them to a potential difference like a battery, what will happen? If I connect this now, right, there will be an electric field here. The electric field will begin to flow from the positive to the negative, 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 such that whenever there is a charge, whenever there is a charge, let's say Q here, if I bring a charge in this distance, remember there's a distance, right? This charge will experience a force. And why did this charge experience a force? Due to the electric field in between the plates, right? So we can say that electric field, because the electric field here is because of the potential difference here, V, right? And there is a distance between the plates. So electric field is equals to V all over D. We'll do more of this when we get to potential electric potential in upcoming chapters. So the unit here is V, right? Meter raised to power minus 1. Are we getting it now? So this is another concept of electric field. But the one you should understand most is, let's do a recap. E is equals to F over Q, and A is equal to what? KQ over R square. So if you can know those three formulas, 1, 2, and 3, we are good to go. Thank you very much for watching. Please make sure you comment, like, and subscribe, and also share to your friends and loved ones. In the next class, we'll be solving problems. Are you getting it now? Yes, we'll be solving problems that are associated with this electric field. Thank you very much.